Hello everyone, I'm Siddharthan. This is the third lead code problem that we are solving, and in this problem we are going to convert Roman numbers into integers. So go to lead code's problem section and sort the questions based on the difficulty, and we are starting with easier problems, and we have already solved two problems of two sum and palindrome number, and now let's start with this Roman to integer thing. So this is the problem statement, and first let's go through this. Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. And each of this would kind of map to a particular value. So I would correspond to 1, V to 5, X to 10, and so on. So for example, 2 is written as double I in Roman numerals, just two ones and added together. 12 is written as XII, which is simply X plus 2. So the number 27 is written as double X, V, and double I, which is this double X plus V plus 2 and so on. So Roman numerals are usually written largest to smallest from left to right, right? So we have largest to smallest from left to right. However, the numeral for 4 is not 4 i's. So we know that. So this we would represent it as I and V, right? So because the 1 is before the 5, we subtract it, making 4. The same principle applies to the number 9, which is written as IX. There are like 6 instances where subtraction is used and so on. So it's basically the same concept, right? So 4 and 9 would be represented differently. So similarly, like all these would come into play when we have this LC and so on. So here the main output that we need to get here is, given a Roman number string, we need to convert it to the integer that it is represented. So that's what we are going to solve, and we can just build our approach to solve the basic numbers of 4, 9, 14 and so on, and all these other things will be sorted by itself. So that's the idea. So before doing this in Python, let's try to understand the approach that we are taking. So for this, I'll maybe come to PyCharm and I'll explain this to you. So let's say that we have a number, so as X, I, and V. So this number basically represents 14, right? So by looking at this, we kind of know it. But when you have a larger number like this, so MC, M, and so on, we couldn't kind of understand that. So that's the purpose of this. So here we know that this is 14. Here you can't say it that this number is kind of like, let's say 10, 1, and 5, because if you take these alphabets separately, that's what it represents, but that's not the case. It represents 14. So now let's fix an approach by which, given a string, we can kind of rightly calculate the number that it represents. So how we would do that is, if you have been given a string X, I, and V, we would reverse it. So let's say that the reversed string is equal to V, I, and X, right? And first you take this V, the last digit, if you see this original number, and in the reverse string we take like the first number, right? So you kind of need that, and get the value. So they have given the values, right? So I, V, and so on. So this we can map it in a dictionary, so that we can do. So no issues on that. So we try to see what does this V represents. So we know that V represents 5. Now you take this and then look at the next number, which is I. So you take this I, which is equal to 1, and you compare if this I is less than or greater than 5. If this second number that you are taking is smaller than the previous number, in this case, if I is less than 5 or if I is less than V, we need to subtract these two. So in this case, the second number, that is I, is smaller than the previous number, which is V. So you would subtract these two things, which is V minus, let's call this as result. So result is equal to V minus I, which would be 5 minus 1, and that would be equal to 4, right? Now this is our result. So you would do this regularly in a for loop. Now you check this with the next number, which is X. So now you take this X is equal to 10, and you check the previous number. So the previous number is I. So you basically compare if X is smaller than I. We know that X is not smaller than I, like the previous case. So you wouldn't kind of do the subtraction. Instead, you add this result to this X. So the final result would be 10 plus 4, and you would get 14. So this is how you can kind of get this value. So let's kind of do the same thing for a different number, that is 16. So 16 would be represented as X V1. right? So this represents like 16. So now let's see. So you would reverse the string. So reverse string would be IVNX. So we know that I is equal to 1, and then you take the next number, which is V. So V is equal to 5. Now again you compare if this V is less than I. So previously we compared V and I in this order. Now this is in a different order. So we compare this. We know that V is not less than I. So what we basically do is add these two things. So just the way like we did here, right? So you add these two things so that you would get I plus V, which is equal to 6. Similarly, you kind of look at this X now and compare X and V. So all these individual alphabets should be compared to the previous alphabet. So you compare X and V, so you know that it's kind of not larger, or basically X is not smaller than V. So you just add this X and the result that you got, which is 6, which is equal to 10 plus 6, and you would get 16. So this is how we are going to solve this, and all the other cases of larger numbers like this LC, D, and all these things will be sorted. So here maybe let's do this in PyCharm, run this on debugger and see like how this is working, and then we can kind of run this in LeetCode. So here I'll create a function and I'll call this as Roman to int, and here we would pass yes as a string. So let's say that yes is the Roman string that we are passing, and here we need to map this, right? So we have this I1 V5 and so on. So we need to map this one. So let me copy this and create a dictionary out of this. So we can say let's call this as Roman values. Maybe you can call this as Roman map. So Roman map is equal to create a dictionary and say I would be 1, and maybe I can just put this in a single line. So I is 1, V is 5, X would be 10, L is 50, C would be 100, D would be 500, and your M would be 1000. Okay, so this is the map that we have. You can maybe once validate this from the one that's given. Okay, so it's 50, 100, 500, 1000 for L, C, D, and M. Okay, so we have the Roman map. Now let's initiate these variables called as result. So result is like what we are kind of adding finally. So I'll initiate this result and the previous value, these two variables. So let's say that result is equal to 0 and previous value is equal to 0 as well. So now, as I said, the first step is to reverse the string. So for that you can just use this simple slicing of string operation. So for let's say a Roman digit in yes of, so when you put double colon and minus 1, these are like simple string operations. So this would reverse a string. Maybe I can show this to you. I'll comment all these things and I'll take a string as yes is equal to ABC and reverse yes is equal to yes of colon minus 1. You can maybe go through or search online like why this is kind of reversing the string and like basically the reason behind this. That's like not complex at all. So here I'll print this reverse string. So this will basically reverse our string. So we passed ABC, and by this particular string operation we have reversed this to CBA. So this is the same thing that we are doing because we need to reverse the string in order to get the number. So I'll kind of delete these things that I've did. Let's uncomment the code that we had. Okay, so for Roman digits and yes, so basically I'm reversing the string and iterating over this particular order. So let's run this. For Roman digit in a reverse string, value is equal to Roman map Roman digit. Maybe I can print this and show this to you. So at each iteration of this particular value, I'm getting the value for let's say V, I, and X from this dictionary that we have created previously. So here I can print and show this to you. maybe print the Roman digit. Roman digit would be the individual letters that we have over here, and the value would be like the actual value that we get from the dictionary. So Roman map is this dictionary. So passing this Roman digit as key, we are getting the value. So I'll print and show this to you. We have to call this. Let's consider the example of, let's say, x1 and 4, xi4, the same thing that we have, and make sure that you're putting this in a string. So v5i1 x10. So we have reversed it and got the values from this Roman map dictionaries. That's what we are interested in. So once you are done with that, right, next step is checking if the value is less than the previous value, just like the way that we did. So here we compared if 5, or in the first case we don't need that in the second letter, right, because you don't have a previous number before this v, this is the first number, so that's why we are initiating it with 0. But again, after that we would compare this I with 5. So here I would compare if value is less than previous value. If that's the case, as I said, we need to subtract these two and store it in the variable called as result. So here I would say result is equal to result minus value. So this you can also write it in a simpler way, like you probably know this if you are having like a programming background. You can just say result minus equal to value. So this is like the same way of saying result is equal to result minus value. So initially when this runs, result value will be 0, right? Else if that's not the case, else result is equal to result plus value. So this is when, I mean, this case occurs when x is larger than I, right? In that case we would add the result, right? So we won't subtract it. So that's the logic that's happening here. So later we would update the previous value. So at each iteration the previous value would take that particular value, right? So at first step, previous value and the result would be 0 when you take the Roman digit value to be v, and the next time I would take the variable value, and previous value, this variable would take the value of v. So it's basically like we are updating the previous value with the previous value itself. So that's how we can do that, and finally we can return this result. It's okay if you don't clearly understand this, we can just run this on debugger and see like how the variable changes, so that like it's making more sense to you. So the main idea here is we reverse the string, take each string, compare it to a previous value. If the value is smaller, we are going to subtract it and take that as the result. If a particular value is larger than the previous value, then we are just going to add it. We won't subtract it, just like the way that we did over here. So this is our simple function, and then I can say output is equal to Roman to int, and here we can say the string to be xiv, which we know that it's equal to 14. So let's run this. Okay, I have to print this output. So here we are getting the value as 14. So similarly we can check this for x, v and I, and this is coming to be 16 and so on. So you can also take a larger number like the one that they are given here and see if we could kind of calculate these values correctly. Again, so this may take some time when you are trying to solve this for the first time, but as you practice more codes and you practice this repeatedly, you would be able to kind of solve this like pretty quickly. So here we are getting the right value to be 58, and finally let's do this for 1994. And run this. So we are getting the output. So maybe in this case we can use the first example of x, I and v and run this through a debugger and understand like how the values are running. So I hope you know how to use a debugger. So go to PyCharm or VS Code, any other IDEs, and you can put a breakpoint. So I'm going to put my breakpoint in this for loop. So you can just move your cursor to the serial number and you will see this red dot, click there. So what this breakpoints do is when you run it on debugger mode, it would stop at this point before executing this line, and you can see the values of all the variables that you have declared, and as you go through the code you would be able to see in real time like what the values of the individual variables are. So that's the purpose, and here I'll click the debugger. right? So it has stopped at line number 7, and at this point the previous values, you can see it here as well, and you can see it like in this place as well. So previous value is 0, result is 0, the one that we have initiated, and we have the Roman map dictionary, right? And then again, so the dictionary has been ordered in alphabetical order, so no issues in that. So you can give this step into my code to run your code line after line and stop at each point and look how the values are. So let's run this. So we know that this s of double colon -1 would reverse your string, right? And once you reverse it, you iterate through this for loop. So Roman digit would first take the value of v. Okay. And now we are going to run this particular line. Value is equal to Roman map Roman digit. So here Roman digit is v, right? So we are going to put that to the Roman map dictionary, get the value which is equal to 5. So let's again step into the code, and here you can see the value as 5. So we have got it from there. Now we compare our value to the previous value. Now v is the first value after we reversed it. We don't have any previous value. The one that we have initiated is 0. So of course the value will always be greater than previous value, because there is no previous value, right? And you would always start with 1, because the minimum number you have is 1. So when this for loop runs for the first time, it will never go through this if condition first time. It will always go through this else, because your value is always going to be greater than the previous value, which is 0. So if you look closely, when I click the step into my code, it won't stop at 10, because that line won't be executed. It will stop at line number 12. Let's see. As you can see, this if condition is not satisfied, so it went here. So if value is greater than previous value, it would go to the else condition, and it would add this value to the result. Result is also 0. So once you add 0 plus value, so value is 5 that we got from this v Roman map. So you would add this, and the value would be 5. Finally, we update the previous value. Now in the next iteration, we are going to take the value I, right? And we need to update the previous value to be 5. So that's what we are going to do. So previous value is equal to value. So once you run this line of code, your previous value will change from 0 to 5. Okay, as you can see. And now when I again run this iteration, this loop runs for the second time, and your Roman digit would be I, the second reverse string, right? Now we would get the value from the Roman map. So I value is 1, we know that. So if you see, this value that you are seeing is for the previous value. So I can run this value has changed from 1, so we got this from the Roman map. Now if you see, this value is nothing but 1, and the previous value is 5, so its value is lesser than the previous value. So we would subtract this result by this value. So what we have discussed here, right? So if I is less than v, in this case we would subtract it and store it in the result. So that's what we are doing here inside this if condition, and this else won't be executed, and then we would update this previous value. Now your previous value will update from 5 to 1, right? Let's run this. It has updated. Now when we run this, the final digit that it's going to take is x. So let's run this, and now your Roman digit changed to x, and when you run it, you get the value to be 10. So we got this from the Roman map, and we check if value is less than previous value. Here value is 10, previous value is 1, so this won't be satisfied, so we will just like add the result and so on. So run this, it goes to the else condition, and finally you would kind of exhausted like all the if conditions, and finally you would return the result. So now result is nothing but 14, and now we are printing it. So you can run this to execute the other part of the code, and you would get 14. So this is how you can convert a Roman string into a numerical value, but again the concept is same. So it just took some time, because I've like explained you all the basic things. So we just get a Roman string, reverse it, compare the digit with the next digit that we are getting. If the next digit is smaller, then we are subtracting that, storing it in a variable called as result. If it's greater, then we are just adding it. So that is like the base concept that we are using. So I'll just copy this entire code and paste it over here, and let's check if it is passing like all the test cases. If it does, we can submit it and validate it with like even more test cases. Okay, so let me just remove all these spaces, and as I said, instead of writing result is equal to result minus value, you can just simply say result minus equal to value, and here you can say result plus equal to value, and so on. This is the code. So first you can run this, so it will be validated against like these test cases. you will see an approved message and green dots. So here they checked it with the test case of triple I. We know that it's 3, so expected output is 3. We are also giving 3, and this is like the next case, and then we have the third case. So once this is kind of approved, we can submit it and it will be validated against even more test cases, and our output or our code will be submitted. And here we are doing a good job of the runtime is 39 millisecond. You can see it beats like 89.47% of users, and even the memory is better. It's beating like 97.47% of user. So this is how, given a Roman string, you can convert it into an integer. There are also like other ways to do this. There can also be like simple ways to do this. If you know, you can maybe post your code as well, so that like others can learn from it too. So that's it from my side, and I'll see you in the next upload. Thanks for watching.